Good morning, everyone. Thank you for joining for our GCSE Maths session this morning. This is, as usual, a foundation session led by our brilliant maths tutor, Evelyn. Should be a really good session today. As you know, the topic this morning is calculating with fractions, and it's part one of two parts on this topic, so should be really useful. Just some housekeeping. So this is an hour-long session, so we'll wrap up around midday, around 12. And if you have any questions throughout or want to participate in any questions that Evelyn's asking, then just pop those in the chat or Q&A. I'm Tilly, I work at my tutor, so let me know if you have any questions for me. And our tutor today, as lots of you already know her, is Evelyn, who studies mathematics at Birmingham University and is really experienced with tutoring, so you're in great hands this morning. I'll just wait a couple of minutes as more people join us and just remind you that if you wanted to watch any of our past recordings of tutorials, you could do so on my tutor YouTube channel. And also, Evelyn and our other tutors have made some really helpful shorter topic videos which are related to all the topics that they've covered so far over the past few weeks. So those should be really helpful if you needed some extra resources for consolidating your knowledge or going over any revision. Cool, are you all ready to go, Evelyn?
Yep, I'm ready.
Nice, have a great lesson, everyone.
Right, thank you. So let me get this one up here. So we're going to be doing calculating fractions today. But before we start, we're going to do a quick recap on what we did last session. So last session, we were doing tables, charts, and diagrams for data. So we looked through frequency polygons, which represent group data in a frequency table on a graph. So that was the one where we drew up straight lines between the different points. We also looked at time series graphs, which look very similar to frequency polygons, only that they represent how something changes over time rather than grouped data. So that's the difference between the two of those. We also looked at bar charts, which show the frequency of events occurring, and the height of the bars represents the frequency of each event. We looked at pictograms, which represent frequency of events using pictures, and pie charts, which is a chart represented by a circle. So the proportion of the frequency is represented by the equivalent proportion of 360 degrees, because 360 degrees is the total angle around a point. And we finally looked at scatter diagrams, which show the connection between two events. So that's when we looked at whether we had a positive correlation, a negative correlation, or no correlation. So just to do a nice quick recap of this material, let's go through a few practice questions. So this is a past paper exam question. So a shop sells raincoats and umbrellas. The scatter graph shows the monthly sales for 12 months, and we have our scatter diagram here. So part A wants us to write down the type of correlation shown by the graph. So since our points, if we were to draw a line, it would be increasing, not decreasing. So this would be a positive correlation. There we go. So we've got a positive correlation for this one here. I can write positive quickly. Yep. So we've got, it's enough to write positive. It's enough to write positive. If you wanted to, you could write strong positive. And the indication to tell you which one you should use, whether it's strong or just positive, it's usually how many marks the question is worth. So if it's 1 mark, it's enough to say either positive or negative. If it's 2 marks, you should definitely say whether it's strong or weak. And then the next part of this question says the manager expects the sales of umbrellas next month to be £60. So draw a line of best fit to estimate the sales of raincoats next month. So first of all, we need to draw a line of best fit, and then see where we can draw up 60 and see where it goes from the graph. So let's get a line, maybe a bit smaller than that. and let's start. So you should always draw your line of best fit, trying to go in the same steepness as the points. And once you've sort of gone in the same steepness, you should try and get the same number of points below your line as there are above your line. So there's 12 points here. So I sort of want 6 points below my line and 6 points above my line. So I'm thinking this would be all right. This sort of line going through your graph. This would be enough to get you the marks for your line of best fit. Then the next thing you want to do is we want to estimate the sales of raincoats next month. So umbrellas cost £60. So if I zoom in, we should go to £60 and draw a line that goes from £60 up until the line and see where it goes across for the sales of raincoats. So 60, if we go from 60, oops, if we go from 60 up until the line, from here, all the way up until the line, and then across, we realize that we get, so obviously use a ruler when you're doing this part, but we get £125 for the sales of raincoats. So that would be our answer, and that would be enough to get you full marks for this question. And that is that's our recap question. Perfect. So let's now look at the next let's now look at fractions, and I don't think it's loaded up properly on here. Here we go. Sorry, my computer's running a little bit slow today. Here we go. Fractions part 1. So today, what we're going to be doing in calculating fractions is we're going to be going through how to order fractions, how to simplify fractions, and how to add, subtract, multiply, and divide fractions. So all of so the 4 operations using fractions. So we've all seen what a fraction is before, and now we're just going to work through how to calculate with them. So fraction shows parts of whole numbers. So as you can see in the top right corner, we have a square, which is split into equally sized 4 smaller squares. And there's one smaller square which is shaded in blue. So since we split it into 4 equal parts, and we've chosen 1 out of the 4, this would represent a quarter of the square, which is shaded. So the numerator, which is the top number in your fraction, represents how many parts we're interested in, and the denominator, which is the bottom part of your fraction, represents how many equal parts we've split our shape or our quantity into. Now, a fraction also represents a division as well. So a quarter is the same as saying 1 divided by 4. So some important fractions to remember as well is if you have the same number as your numerator and the same number as your denominator, then it always equals 1. So if you had 7 over 7 or 10 over 10 or a million over a million, it's always going to equal 1. Okay, and if you have a whole number, so 5 over 1, so any number on your numerator and 1 on your denominator, that would be the same as representing a whole number. So 1 second, someone's asked a question on scatter diagrams before we quickly move on. So how do you determine whether you start the line at the bottom or the top? It doesn't matter, as long as your line goes through, so with the scatter diagram, as long as your line has the same steepness as all your points, and you have the same number of points below your graph than above your graph as well, it doesn't matter. It doesn't matter where you start it, whether it's the bottom or the top. Okay, so fractions is just parts of whole numbers. Yeah, so hopefully you can pick it up as we go along. So 5 over 1 is the same as 5. If you had something like 10 over 1, that's the same as 10. any number which is over 1 is the same as the whole number as the numerator. So I'm going through equivalent fractions now. Now, since fractions are parts of whole numbers, you can have something called equivalent fractions. So if we look on the right, we have a fractions grid here. So we have each row is exactly the same shape, exactly the same rectangle, only that it's split into different number of parts. So the top one is split into 1, it's just the whole thing. The second one is a half, and so on and so forth. And what we can notice is that if we look at a quarter, this is the same amount of space shaded as there are for 2/8. So a quarter is exactly the same as 2/8. Now the way to work out equivalent fractions is to multiply both your numerator and your denominator by exactly the same number. So here, this is the same as timesing by 2 on the numerator and timesing by 2 on the denominator. That's how you get equivalent fractions. A quarter is the same as 2/8. Now, if we were to look at a half here, so if we shaded in this section, this area is exactly the same as 2 quarters. Now that would be, so a quarter plus a quarter would be 2 quarters. So we've got 2 quarters equals a half. Yeah, and if we continued, we'd also realize that if we shaded in these squares as well, that means that 3/6 would be exactly the same as a half as well. And it would go on as well to, if we were to shade in 4/8 on top of that. So 4/8 is also the same as a half. Now, if we notice as well with our fractions, each of our numerators is half of the denominator. So it would be half anyways, wouldn't it? Because 4 is half of 8, 3 is half of 6, 2 is half of 4, 1 is half of 2. So it would be a half. So here's exactly what I was doing, just with just a little bit bigger, so you can see it a little bit better. So a half is same as 2 quarters, same as 3/6, same as 4/8. So you can find any equivalent fraction just by multiplying your numerator and your denominator by exactly the same number. So if we did that here, we'd get multiplied by 2. And if we were to do the same thing with a half and 3/6, if I use a different color, it would be multiplying by 3, wouldn't it? And then if we were to do that with 4/8, it would be multiplying by 4, and it would go on in a similar way. So now that we know what equivalent fractions are, we're now going to be able to simplify fractions. So to simplify fractions, we need to find a common factor between the numerator and the denominator, then divide both the numerator and the denominator by this number. And then if your new fraction that you get after you do this has a common factor between the numerator and denominator, then we're going to repeat it until we can't find any common factors between your numerator and your denominator. Yeah. So if I go through an example, this will probably make a little bit more sense. So there's 2 different ways of doing this. We could either find the highest common factor and do it all in one step and then we'd be done, or you can do it using different common factors as you go along. So let me show you exactly how we do this. So with the highest common factor between 16 and 20 is 4. So what I'm going to do is I'm going to divide my numerator by 4 and my denominator by 4. Remember, when you're simplifying fractions, you have to do exactly the same thing as you do to your numerator as to what you do with your denominator. So we're going to do 16 divided by 4, which would be 4, and then 20 divided by 4, which is 5. And that would be our simplified fraction. And that's in its simplest form, because the only other common factor 4 and 5 have is 1, and anything divided by 1 is itself. So that's in its simplest form. Now, if we didn't want to do the highest common factor, or if we couldn't remember what the highest common factor is between two numbers, we could do it a different way. Just divide it by numbers which you know it goes into. So 16 and 20, they're both even numbers, so we know they divide, we know that 2 goes into both of them. So we can first divide the numerator by 2 and divide the denominator by 2. So 16 divided by 2 is 8, and 20 divided by 2 is 10. Now here we have two even numbers again. We have 8 and 10, so we know 2 goes into both of these numbers as well. So we can continue. We can do 8 divided by 2 and 10 divided by 2. And then we get, so 8 divided by 2 is 4, and 10 divided by 2 is 5. And then that's where we stop, because there's no more common factors between the two. Yeah, so you can decide to do it using the highest common factor way, or you can decide to do it using the common factor way. When you get to much larger numbers, it would be easier to do the common factor way. You just have to remember your different factors for different numbers. Yeah, so the best way to do it is if it ends in 5, it's a multiple of 5, or if it ends in 0, it's a multiple of 5. If it's an even number, it goes into 2. So those ones are usually the really popular ones to choose when you're finding common factors. So before we move on, let's go through a quick quiz. So which of the following fractions is 24 over 80 in its simplest form? So is it A, 6 over 20? Is it B, 24 over 10? Is it C, 2 over 5? Or is it D, 3 over 10? So 24 over 80, let's try and work it out. So I'm going to use the common factor way. So we've got 24 over 80. Now I know that these are both multiples of 4. So I'm going to do 24 divided by 4 and 80 divided by 4. So 24 divided by 4 is 6. And then 80 divided by 4 is 20. So I've got 6 over 20 first of all. Now, some of you might have said A, but 6 over 20 is not a fraction in its simplest form. So we still need to continue. Now we know that both of these numbers are even numbers, so I'm going to divide it by 2 next. So 6 divided by 2 is 3, and 20 divided by 2 is 10. So our answer would be D, 3 over 10. And hopefully that makes sense to all of you. Hopefully you see where I've got 3 over 10 from. So let's continue with an example question now. So here we again want to write a different fraction in its simplest form again. So we've got 18 over 40. So we're going to do it exactly the same way. So you write your fraction and see what common factors it has. So they're both even numbers, so I would just start with dividing it by 2. So we've got 9 over 20. And that would be it, because there's no more common factors between 9 and 20. So that would be your answer in its simplest form. So let's now move on to the next part of working with fractions, calculating fractions. So another thing which you have to know for your foundation GCSE is how to order fractions in terms of their values. So the first thing that you should do is find an equivalent fraction for each of the fractions that they give you, and with common denominators. So all that means is that each of your fractions or equivalent fractions that you find, they all have to have exactly the same denominator. Now, since all your denominators are the same by this point, you can just order your fractions depending on the value of their numerators. So always remember to use the original fractions in your final answer. So always give your answer in terms of the fractions that they gave you, rather than the equivalent fractions that you've worked out. So I'm going to show you exactly what I mean with this example question. So we want to place these fractions in ascending order. So we've got a half, 2 over 3, 7 over 12, and 5 over 6 and a quarter. So first of all, I want to find equivalent fractions for each of these fractions with exactly the same denominator. So I need to find a common multiple for each of the denominators. Now we have 2, 3, 12, 6, and 4. So using my knowledge of multiples and factors, I know that each of these numbers is a factor of 12. So I would like to change all of my fractions into equivalent fractions with a denominator of 12. So 7 over 12 is done for me already. So I'm just going to write this one down here. Now I want to change a half into something over 12. Now I know that I would need to multiply my denominator by 6 to get to 12, because 2 times 6 is 12, which means that I also have to, if whatever I do to my denominator, I have to do exactly the same to my numerator. So I'm going to multiply my top number, my numerator, 1 by 6 as well. So I'm going to get 6 over 12. So that's the equivalent fraction to a half, 6 over 12. So now I've got another number with 12 as a denominator. I'm going to do the same thing for the next one. So I know to get from 3 to 12, I need to multiply by 4. So I also need to multiply my 2 by 4. So I've got 8 over 12 over here. Then finally, then next I've got 5 over 6. So I need to multiply by 2. So I've got 10 over 12. And then finally, I've got a quarter. So I'm going to multiply this with 3. So I've got 3 over 12. So now I've got all of my fractions, the equivalent fractions with a common denominator, which is 12. So the last thing to do is now place it in ascending order, depending on the value of my numerators. So the smallest numerator is the 3 over 12. So that would be the first one. That'll be the one that would go first, because we want to place it in ascending order. So we start with the smallest and go up to the largest. So it would be 3 over 12, then 6 over 12, 7 over 12, 8 over 12, and 10 over 12. Now, the last point that I made in the last slide was saying that you have to remember in your final answer to write down the original fractions. So those are the fractions that they gave you. So it's all of these ones at the top. So a half, 2/3, and so on. So I know that 3 12s will go first. So I'm going to write a quarter as my first one, because a quarter is my smallest fraction. It's exactly the same thing as 3 12s. Then the next one would be 6 12ths, which is the same as a half. So I would write a half next. Then it would be 7 over 12ths, which is exactly the same as the original fraction. Then it's 2/3. And then finally 5/6. So to get full marks, if this was an exam question, to get full marks, you would have to leave your answer as the one in purple. You'd have to use the original fractions, not the fractions that you made up. So let's do a quick quiz again then. So we've got which of the following is the smallest fraction? So is it 5th? Is it 8 over 15? Is it 1 over 3? Is it 2 over 25? Or is it 7 over 25? So to find the smallest, what I would suggest you do is you do exactly the same thing as what we did in ordering fractions. So we're going to make all of these into equivalent fractions, but with common denominators. So all of these are factors of a particular number which is already on this slide. So all of the denominators, 5, 15, 3, 25, and 75, are all factors of 75. Yeah. So to get to 75 from 5, you need to multiply by 15. So we're going to do 5 times 15 and 1 times 15. Sorry, 1 times 15 here. So we've got 15 over 75. Now, we already can tell that 15 over 75 is much bigger than 7 over 75. So obviously this one can't be the smallest one. So we can cross that one out. The next one, to get from 15 to 75, well, that's just going to be the opposite of what we just did. It's going to be 15 times 5, which gives us 75. So we're going to multiply 8 by 5 as well. Now, 5 times 8 is 40. So we get 40 over 75. Now, this is a lot bigger than 7 over 75, so it won't be that one. Next one, to get to 75 from 3, you multiply by 25. So now you have 25 over 75. Now this again is bigger than 7 over 75, so this also isn't going to be the smallest. And then the last one that we compare with our 7 over 75 is 2 over 25. Now we can times 25 by 3 to get to 75. So we've got 6 over 75. Now this is smaller than 7 over 75, so this would be our answer. So 2 over 25 would be the smallest. So hopefully ordering fractions and finding the smallest number does make sense to you. If not, we've got another example question just to go through it the final time before we move on to adding and subtracting. So we've got these fractions here, and we want to order them in descending order. So we need to find a common denominator for each of these fractions. So all of them are actually factors of 48. 6 goes into 48, 24 goes into 48, 4 and 8 also go to 48, and obviously 48 goes into 48. So to get from 6 to 48, we're going to multiply by 8. So we're going to multiply the numerator and the denominator by 8. So we've got 8 over 48, that's our equivalent fraction. The next one is 7 over 24. Now to get from 24 to 48, we multiply by 2. So now we've got 14 over 48. The next one is 1 over 4, so we multiply 4 by 12. So now we have 12 over 48, 23 over 48. We can just write down, because this already has 48 as a denominator, and then 3 over 8. So we can times 8 by 6. Now 3 times 6 is 18 over 48. So now we want to place it in descending order. So we want to start with the largest and go down until we get the smallest. So the largest is 23 over 48, because that's our largest numerator. Then the next one would be 18 over 48, then 14 over 48, 12, and then 8. So what we want to do now is we want to write down the original fractions, not the fractions that we've just calculated. So it would be 23 over 48 first. That's exactly the same. Then our next one would be 18 over 48. So that's 3 over 8. So we'd write 3 over 8. The next one would be 14 over 48. So we've got 7 over 24. Then it would be 12 over 48, which is a quarter. And then 4 over 48, which is a 6. So that is the final answer, and you get 4 marks if you wrote this down in your exam. So a few things to be careful of. Make sure that you read in what order you need to write it down in. They will either say ascending or descending, or starting with the smallest or starting with the largest. So make sure that you pay attention to that. And the best way to sort of make sure that you don't get the answer wrong is always write your equivalent fractions either directly next to the original fraction or underneath it, so you can match up which fractions are equal to which ones, rather than having work all over the place and then you can't figure out which one is which. So now we can move on to adding and subtracting fractions. So adding and subtracting, the first thing that you should do is exactly the same for both. You need to change your equivalent fractions. You need to change your fractions, into equivalent fractions with common denominators. So it's exactly the same as what we were doing with ordering, only now we're doing it with two numbers, and then once we have done that, we can add the numerators or subtract the numerators. There's only the numerators that we're working with, not the denominators. So examples here, we've got 3/6 plus 5/12. Now I know that both of my denominators are factors of 12. So I can write 3/6 as something over 12. Now I would have to multiply 6 by 2. So I'm also going to multiply my 3 by 2. So I've got 6/12 plus 5/12. Now I'm just going to add only my numerators. So 6 plus 5 is 11. So my answer would be 11/12. And that's how we add fractions. Then we do it in a similar way for subtraction. So you've got 7/11 and 3/8. Now, I know that a common multiple of each of these, so 11 and 8, are both factors of 88. So I'm going to change both of these into fractions over 88. So to get to 88, I'd have to multiply this one by 8. So I'm going to multiply my numerator by 8. So 7 times 8 is 56. So we've got 56/88. And then to get from 8 to 88, we multiply by 11. So now we've got 33/88, because 3 times 11 is 33. And then we subtract only the numerators, so our answer would be 23/88. And that would be our answer. So adding and subtracting, we just make sure that we have common denominators and work with only the numerators. Now, multiplying is a little bit easier. But before we go on to multiplying quickly, let's go through this quiz. So which pairs of fractions sum to make 1? Is it 1/2 and 1/3? Is it 4/7 and 21/49? Is it a quarter and a fifth? Is it 4/9 and 29/54? So if we look at A quickly, so I want to find a common multiple between 2 and 3. Now, a number that I can think of is 6. Also, what I'd like to say about all of these is, as long as you can find a common multiple, it doesn't have to be the smallest one. It could be, we could say that a common multiple would be 12, and then we multiply a half by 6/6, and then a third by 4/4. Either one, you're still going to get exactly the same answer. Especially when you simplify your answer at the end as well. It doesn't matter, as long as you both have both of your denominators are exactly the same. So here I'm going to pick 6 because it's quicker. So I'm going to multiply both my numerator and my denominator by 3. So I've got 3/6. And then here we've got, we need to multiply by 2. So here we've got 2/6. Now, 3/6 plus 2/6 equals 5/6. So this doesn't equal 1 because we want to get to 6/6 if that was the case. And this doesn't equal that, so it can't be A. The next one, 4/7 and 21/49. Now I know that both of these are factors of 49. So 21/49 can stay the same. But 4/7, I need to multiply my numerator and my denominator by 7. So 4 times 7, we've got 28. And then 7 times 7, we've got 49. So if I added these together, it would give me 49/49, which is exactly the same as 1 because they're both the same number on the numerator and the denominator. So our answer for this one would be B. Now, if we went through and calculated for C and D, we'd realize that those also, like A, don't give us an answer of 1. So B would be our only answer for this one. So And a quick example question as well before we move on to multiplying. So what is the solution of this sum? So we're going to do exactly the same thing as what we did for ordering as well. Make all of them have exactly the same denominator, and then add them together and see whether we can simplify it afterwards. So these are all factors of 81. 3 goes into 81, 9 goes into 81, 27 goes into 81. So to get from 3 to 81, we need to multiply it by 27. This sort of question could potentially come up in a non-calculated paper as well. So be aware of that and make sure that you do know your factors and your multiples. So here we could write this as 27 over 81. Our next one, 1 over 9, we know that 9 times 9 gives us 81, so we need to multiply our 1 by 9. So we've got 9 over 81. Our next one, 27 multiplied by 3 gives us 81, so we've got 1 times 3, so we've got 3 over 81, and then we can add our 1 over 81 at the end as well. So we've got 27, so we're just going to add our numerators because we're adding our fractions. So it's going to be 27 plus 9 plus 3 plus 1 all over 81. So this would give us 40 over 81. Now 40 and 81 do not have common factors. For 81 only really has 1, 3, 9, 27 and so on. 40 does not have any common factors with 81, so this would be our final simplified solution, 40 over 81. So hopefully adding and subtracting makes sense. So now we're going to move on to multiplying and dividing. So first of all, multiplying. So multiplying fractions is actually probably the most, the simpler one. You don't have to move around your fractions or make equivalent fractions. All you need to do is multiply both of your numerators together and then multiply both of your denominators together. So this answer would be 4 times 2, which is 8, over 7 times 3, which is 21. That's it. That's multiplying fractions. If they ask you to leave it in the simplest form, then make sure that you do simplify it. In this case, 8 and 21 do not share common factors. So this would be the simplest form for this answer. Now, dividing fractions is a little bit different. You can't just divide the two together. So here's like a little method which would help you to remember how to work with dividing fractions. So we're going to keep the first fraction exactly the same. So we're going to have 4 over 7, keeping the first one exactly the same. Then we're going to change the divide sign to a multiply sign. And then the last step is to flip the second fraction. So to flip a fraction is also the same as the reciprocal of the fraction. All that means is turn it upside down. So now we have 3 over 2 instead of 2 over 3. And now we just calculate what is 4 over 7 times 3 over 2. So 4 times 3 is 12. And then 2 times 7 or 7 times 2 is 14. So we've got 12 over 14. Now, if we wanted to simplify this fraction, I know that both of these are even numbers. So if I use a different color pen, I can divide these by 2. So we would get, 12 divided by 2 is 6, and 14 divided by 2 is 7. So our final answer would be 6 over 7 in its simplest form. But to divide fractions, always remember keep, change, flip. So keep the first one, change the sign, and then flip the second fraction. So let's look at a quick quiz at this. So which is the correct solution for 3 over 4 multiplied by 1 over 6? Is it 18 over 4? Is it half? Is it an eighth? Or is it 9 over 2? Now, I would say once you do work it out, leave it in its simplest form. Yeah. So let's look at it. Let's see if we have to simplify it anyways. So 3 over 4 multiplied by 1 over 6. So multiplying, all we need to do is multiply the numerators together and the denominators together. So 3 times 1 is 3, and 4 times 6 is 24. And then if we were to simplify this, we know that both of these are multiples of 3. So I can divide the numerator by 3 and my denominator by 3. So I would get 1, because 3 divided by 3 is 1, and then 24 divided by 3 is 8. So my answer would be C, 1/8. So hopefully multiplying makes a lot of sense. So now we're going to go through an example question on dividing. So we want to calculate 1 over 9 divided by 2 over 3, sorry. So we're going to do exactly the same method as we discussed. I'm going to use this one again. So we've got keep. So we're going to keep the first fraction exactly the same, 1 over 9. Then we're going to change. So we're going to change the divide sign to a multiply sign, and then we're going to flip. So we've got 3 over 2 instead of 2 over 3. And then we're going to calculate it. So 1 over 9 multiplied by 3 over 2. So we've got 1 times 3, which is 3. Then 9 times 2, which is 18. And then we need to see whether we need to simplify it. So is it in its simplest form? So 3 and 18, we know that they're both multiples of 3. So we can divide both the numerator and the denominator by 3. So 3 divided by 3 is 1, and 18 divided by 3 is 6. So our answer would be a 6. 1 over 9 divided by 2 over 3 would be a 6. So that is everything that we're going to learn today. So let's go through a few exam past paper questions. So usually working with fractions, calculating fractions comes up in the first part of your papers. Doesn't really matter which exam board you're taking. They're usually like the first sort of questions that you open up with. And they're usually the simpler ones, so like say multiplying, adding, subtracting, or ordering. So let's look at this one. This one's from AQA paper 2017. Zoom out a little bit. So we want to work out 5 over 8 multiplied by 3 over 4. So all we need to do is multiply the 2 numerators together and the 2 denominators together. So 5 times 3 is 15. And then 8 times 4 is 32. And then 15 and 32 don't share any common factors. So that would be our final answer, 15 over 32. And then part B is now asking us to work out 2 over 3 minus a quarter. So remember, when you're adding and subtracting fractions, you need to make sure your denominators are exactly the same. You need to make sure you have a common denominator. So 3 and 4, they're both factors of 12. So I'm going to multiply my 2 over 3 by 4s. So multiply my 3 by 4, and then I have to multiply my numerator by 4 as well. So I've got 8 over 12. And then I'm going to multiply my quarter by 3s as well. So my denominator by 3 and my numerator by 3. So 1 times 3 is 3, 4 times 3 is 12. So now I've got 8 over 12 minus 3 over 12. And remember, when we are subtracting, we only work with the numerators and keep the denominator exactly the same. So 8 minus 3 is 5, and then we keep our denominator the same. So our answer here would be 5 over 12. And 5 and 12 don't have any common factors, so that would be our final answer. And you would get 4 marks for this question if you did, if you had these answers. Perfect. So we have reached quarter 2. Does anyone have any questions? Perfect. I don't think we have any questions, which is good. Hopefully I've explained everything pretty well. So what we can do is we can go through some more exam past paper questions and some more examples. So this one is another past paper question. This one's from edXL 2017. So this one, they want us to write these fractions in order of size. So starting with the smallest fraction. So remember what I said, when you're ordering fractions, you want to make sure that you write equivalent fractions all with exactly the same denominator. So we want to find the common denominator. So 5, 30, 2 and 15, we know that they're all factors of 30. 5 goes into 30, 30 obviously goes into 30, 2 goes into 30 and 15. So let's write down their equivalent fractions sort of underneath each one and then order them. So 2 over 5, to get from 5 to 30, we'd need to multiply by 6. So we need to also multiply our numerator by 6 as well. So 2 times 6 is 12 over 5 times 6, which is 30. So we've got 12 over 30 here. Then we've got 11 over 30, which is exactly the same. You don't need to change that. Then a half. So to get from 2 to 30, we need to multiply by 15. So 1 times 15 would be 15, and then 2 times 15 is 30. And then our last one, 7 over 15. So to get from 15 to 30, we need to multiply by 2. So 7 times 2 is 14, and then 15 times 2 is 30. So starting with the smallest and putting them in order, we'd have 11 over 30 first, then 12 over 30, then 14, then 15. So remember, for our final answer, we need to make sure that we're writing down the original fractions that they gave us and not the fractions that we just calculated. So our first one, our smallest one, is 11 over 30. And that's exactly the same because that's the one that they gave us. So that would be the first one that we write. And the next one is 12 over 30. Now that's the same as saying 2/5. So 2/5 would be our next one. Then we have 14 over 30, which is the same as 7/15. So 7/15 would go over here. And then our last one is 15 over 30, which is the same as a half. So to get your full 2 marks, you need to make sure that you write down the original fractions. If you did in your exam write down these fractions, you wouldn't necessarily get, it's not necessarily wrong because they are equivalent fractions, you just won't get 4 marks, you'll only get 1 out of the 2 marks. So it's a silly mistake. And it's a very easy mark to lose, so try not to forget to do that in your exam. So another example question here, let me check, is there any more questions? I don't think there are. All right, that's good. So the next one is circle the fraction greater than 3 over 10. So we have a third 3/11ths, 4/15ths, 29 over 100. So what I would say is, instead of writing down all of these fractions with exactly the same denominator, including 3/10, that's going to take a while because it's going to be a very big number, because you have to find a common multiple between 11 and 15. So it is going to be a big number. What I would say is do them individually with the 3/10. So work out a common denominator with 3/10 and a third first. If that doesn't work, then work out a common denominator with 3/10 and 3/11, and so on. So let's do the third first. So 3/10 and a third. So a common multiple between 10 and 3 is 30. So 3/10, we need to multiply the 10 by 3 to get to 30. So we need to multiply our 3 as well by 3. So let me just write 3/10 and 1/3 over here first. So we want to turn this into something over 30. So I'm going to multiply my 10 by 3 to get to 30. So we've got 3 times 3 is 9 over 30. And then to get to 30 from 3, you need to multiply by 10. So here we've got 10 over 30. So 3/10 is 9 over 30, and then a third is 10 over 30. Now, is a third greater than 3/10? It is, because 10 is greater than 9. So this would be our answer. So luckily we got our answer first time round. Now, if we tried it with each of the other ones, like if I show you a quick example with the next one. So if we were to do 3/10, if I change the colours back as well quickly. If I was to do 3/10 and 3/11, we'll see what happens, since this one was quite quick. So a common multiple with 10 and 11 would be just multiplying the two of them together. So it would be 110. So I need to multiply this one by 11. So 10 times 11 would give me 110, which is, so we've got 3 times 11, we've got 33 over 110. And then here we need to multiply by 10. So here we've got 30 over 110. So we can see 30 is less than 33. So this one definitely wouldn't be the answer. So luckily we got our answer first time round. In the exam, it might not be as simple as that. You might have to go through all of them first before you get to your answer. But hopefully this makes sense. A quick tip is if you have numbers like 10 and 11 and you're struggling to find a common multiple, or if you have larger numbers which you're struggling to find a common multiple, the best way to do it is to multiply them with each other. So 10 times 11 and 11 times 10. It's exactly the same calculation, so you're going to get exactly the same denominator. So that's a good trick if you're struggling a little bit with finding a common denominator. So let's look at the next question. Let me see if there's any other questions which anyone is asking as well. Yes, someone suggested that you could convert them into percentages to save time. Yeah, you absolutely could. The only reason why I'm not doing that here is because I'm going to go through fractions and percentages on Wednesday. So we can see how we can use that as well on Wednesday. Perfect. So the next question that we're going to look at today is this one here. So we've got 17 counters in the bag. The table shows the number of counters of each colour. So we've got 7 red, 2 blue, 5 yellow, and 3 green. So what fraction of the counters are blue? So remember, a fraction is part of whole amounts. So we have a whole amount of 17 counters in the bag, and we have 2 which are blue. So our answer would be 2/17. So out of 17, only 2 are blue. That's your answer for that question. They do try to they do like to ask you questions, sort of worded questions with fractions as well. So make sure that you don't get too confused with those also. I think I have another question, more on worded ones as well, which we can go to after this one. So here we have a list of 4 fractions. So one of these fractions is not equivalent to a quarter. So write this fraction down. So what I would suggest is there's 2 ways that you could do this. You could either simplify each of the 4 fractions and see whether they give you a quarter back, or you could multiply your 1/4 and try to get the same denominator for each of the fractions that you have and see whether the numerator is the same. So for instance, if you were going to do that method, what you could do is, to get from 4 to 16, you multiply by 4. So 4 times 4 is 16. So you need to also do the same thing. If I write this down, you would also need to do the same thing with your numerator. So you would get 4/16. So this is equivalent. So that's not the answer. You could do it that way. That way it does take a little bit longer. I would say just simplify each of your fractions. The reason why I say this is because a quarter is in its simplest form anyways. So when you simplify each of the other fractions, if it is equivalent to a quarter, you'll get a quarter as your simplified fraction. So let's do 4/16 simplified. So we already know that 4/16 is a quarter, but if we were to simplify it, we know that 4 is a factor of 4 and 16. So if we did divide it by each other, so 4 divided by 4 is 1, 16 divided by 4 is 4. So we've got a quarter, so it's not this one. Let's do 2/8. So we know that they're both even numbers. So we could divide both the numerator and the denominator by 2. Remember, do exactly the same thing for your numerator as you do your denominator. So 2 divided by 2 is 1, 8 divided by 2 is 4. So again, we get a quarter, so it can't be this one. Let's try 15/60. Now, they're both multiples of 5 because one ends in 5, the other one ends in 0. So we know they're both multiples of 5. So we can divide by 5 for, we can divide by 5 for each one. So we've got 15 divided by 5, which is 3, and then 60 divided by 5, which is 12. And then we're not done yet. This isn't in its simplest form yet, because 3 and 12 are both multiples of 3 as well. So we can divide both the numerator and the denominator by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So we get a quarter again. So the only one left is 3/9. Now, if we did simplify this, this would be 1/3 because they're both multiples of 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. So 3/9 is not equivalent to a quarter. So I would say we probably, if there's no more questions, we probably have time for another example question, which is this one. So again, what I was saying was that they do like to ask you worded questions in terms of fractions. So here is the last question we're going to go through today. So there are 9 pens in the box, 5 pens are red, the rest of the pens are green. So what fraction of the pens are green? So if we have 9 pens in the box, 5 are red and the rest are green. If we did 9 take away 5, we get 4. So we know how many pens in the box are green. So 4 out of the 9 are green. So our answer would be 4/9. And hopefully that sort of concludes calculating with fractions. I hope it all made sense.
Brilliant, thanks so much for the session. I just had one question, which was, is there physics? Yes, we do have physics sessions, and we have one coming up at 2 p.m. today, which is on magnetic fields of electrical currents. So if you want to join us for that, please feel free to do so. We also have biology this afternoon at 3:15 as well. But if you just join us for our foundation math sessions, then hopefully see you on Wednesday at 11 for part 2 of calculating fractions. So thank you very much, Evelyn, for the session today, and for everyone who joined, thank you for participating, and we'll see you in another session soon. Bye.
Bye.